Hello, my name is Thomas Rodriguez, and I will be going over my Lab 2 for Physics 2212. So to introduce this lab, the purpose is to further analyze from Lab 1 how electric interactions can affect two charged pieces of tape using a line of charge calculation instead of a point charge calculation. For the fundamental physics principles I use, the first is Coulomb's law, which is that the electrical force is equal to K, which is the electric constant, times Q1 times Q2, Q1 and Q2 being the two charges, divided by R squared times R hat, where R is the separation distance between the two charges, or the charge of the tapes. Then there's also gravitational force acting downward on the two charged pieces of tape, which is G equals 9.81 meters per second squared. And then there's also Newton's second law, F equals ma, acting on these pieces of tape. To represent the electrical forces and fields of this experiment, would model this through a free body diagram. For the system, it would be the tape that was being held by two members of our group when doing the experiment. And then the surrounding would be a tape that's attached to both eraser blocks, as well as the electrical forces and gravity acting on the pieces of tape. And the main result is that with the line of charges calculation, the new charge of the tape is 2.39 times 10 to the negative 8 coulombs. So to go over the Lab 1 experiment that is applicable for this Lab 2 experiment, step 1 is to charge two pieces of tape, also called U-tapes, by ripping it on top of a base tape. And step 2 is to place one of the U-tapes between the two eraser blocks. And step 3 is that you would place the second U-tape next to the first one, and then because they have the same charge, they would naturally repel. And then when they repel, you would measure the separation distance. So before I go over the code, I'll go over how I calculated for the charge using this new line of charge calculation. So for the gravitational force, I use F equals mg, m being the mass of the object, or mass of the tape, which is 2 times 10 to the negative 4 kilograms. And then the electrical force would be equal to the gravitational force, because net force would be 0 in this case. And then when calculating the charge, I use the formula, the electrical force equals the electric field times the charge. And for the electric field, I use the formula of the electric field of a uniform rod, because in this case, the tape is acting as a uniform rod where all of its charges are evenly distributed across its length. And then in this formula, R would be the separation distance of the piece of tape, which in my experiment was 0.0254 meters, and L would be the length of the tape, which is 0.2 meters, also measured from the experiment. And then when putting all those values and calculating it, I would get that Q is equal to 2.39 times 10 to the negative 8 coulombs. So for the code, these are the initial conditions, some of which I've talked about already. And then for the functions, there's this electric field function that was also in Lab 1. Then there's a new function that I added for this Lab 2, which is a line of charge function. And what this would do is it would include different sections of the tape, and it would create a point charge for each section of the tape with its own mass and charge. And then I created a top tape and a bottom tape with that separation distance of this tape distance variable. And then this nested for loop would add an electric field arrow for all of the individual point charges that I made that were going across and are evenly distributed along this piece of tape. And then for the magnitude of the charge of one piece of tape, it would be 2.39 times 10 to the negative 8 coulombs. Some assumptions I made was that I would ignore air resistance and assume that there was the same amount of charge being evenly distributed along the tape, and I would approximate the charge of the tape with a line of charge calculation. So this is the model produced by the computation. So the white arrow would be the electric force, the yellow arrow would be the gravitational force, and the green arrows would be the electric field of each individual point charge spread across this line. So to conclude, some possible errors was that friction and air resistance may have played a part in this experiment, and that touching the tape could have led to a loss in charge of the charged pieces of tape. For the what if question, what if I modeled each of the tapes as a single point charge? Well, that would have been the value that I got in the Lab 1 experiment, which was 1.18 times 10 to the negative 8 coulombs. And then in this experiment, I got 2.39 times 10 to the negative 8 coulombs. So for this what does it mean question, do these estimates differ? Yes, they do. And which value is more likely closer to the real value is probably the line of charge calculation, because it incorporates measuring specific instances of the tape instead of measuring the charge at one specific point of the tape, therefore making it more precise. Thank you for listening.